is Algebra 2, Lesson 61. We're going to be doing more chemical mixtures, and we're starting on page 261. In the chemical mixture problems we've worked so far, we have mixed two solutions of two different concentrations to get a mixture that has a different percentage of concentration. The new percentage has to fall between the percentages of the original concentration. It can't be greater or less. So, if we look at this graph on this page, they have a 15% iodine solution and a 60% iodine solution in these beakers, and they're pouring them into this bowl. The new concentration will be somewhere between the 15% and the 60%. It can't be less and it can't be more. In our new problems, we're going to begin with a given mixture, and we'll either add something to it or take something away from it. Just like in this type A problem, the equation will make a statement about one of the components of the mixture. So, here's an example. How much water must be evaporated from 100 gallons of a 10% brine solution to get a 40% brine solution? A brine solution is salt and water. Normally in a problem, we will choose whether we are going to do the problem based on water or based on salt. This time we're going to do it both ways, so you can see that either way gets the same answer. So, first we set up the problem. Wi means the initial amount of water, minus, because we're going to be taking away water, it's going to be evaporating, water out, or water 0, and that equals water final. So water initial minus water that left equals the water at the end. And we're setting up the same equation over here for salt. Okay, now we have our cute little mixture containers, and we're going to start setting up the problem. So our original mixture was 100 grams, so this goes in the first container. On both sides. We evaporated some, so E for evaporated goes in the second container on both sides. The final mixture is the original mixture minus what was evaporated. So 100 minus E goes in the final container. Now we're going to multiply each container by the proper decimal so that the container times the decimals represent water, and on this side they will represent salt. If we have a 10% brine solution, then 10% of it is salt and 90% of it is water. So on the water side, it's going to be, the original amount was 90% of the 100 gallons was water, and because we're turning into a decimal, it turns into a 0.9. And over here, 10% of the original 100 gallons is salt. For the second term, we consider what evaporated. In this case, it's water that's evaporating. Salt does not evaporate. So we're going to leave the E here in the water side, but in the salt side, nothing evaporates. So we can just take this out, or we can multiply it times 0, because none of the salt evaporates. We want to end up with a 40% brine solution, which means in the end we will have 60% water and 40% brine. So over here we will multiply the 100 minus E container times 0.6 for 60%, and over here it'll be 0.4 for 40%. Now we can solve for E. So on this side we have 0.9 times 100, which is 90, minus E, which equals 0.6 times 100 is 60, minus 0.6E. Okay, let's move the 60s over here and the e's over here. So this cancels and this cancels. Oop, that's a 60. And so we have 30 equals negative 0.6 plus 6 is 0.4e. And now we're going to divide by 0.4 and divide by 0.4. 30 divided by 0.4 is 75. So we would have to evaporate 75 gallons of water from the 10% brine solution to get a 40% brine solution. That's a lot of the water. Okay, let's solve for this side. So we have 0.1 times 100, that's 10. This is just 0. So 10 equals, and multiply this through, that will be 40 minus 0.4e. Move the 40 over here. And we have negative 30 equals negative 0.4e. Divide by negative 0.4. Those cancel and we're left with E equals 75 gallons. So it doesn't matter if we start with the salt or the water or the salt, the answer, how much needs to evaporate, is going to be the same. When Frank and Mark finished milking, they found that they had 900 pounds of milk that was 2% butterfat. How much butterfat did they have to add to raise the butterfat content to 8%? Okay, first of all, the people who made this problem, they're not farmers. Okay, besides that, whole milk is a mixture of skim milk and butterfat. And apparently they have skimmed off some of the fat, so now they have 2% milk, and they want creamier milk, so they want to raise the amount of butterfat to 8%. Okay, this time we're adding instead of subtracting, and we will do this in terms of the butterfat. So the butterfat initially plus the butterfat that's added, I'm just going to put an A for added, is going to equal the butterfat at the end. Okay, so butterfat, the initial amount of butterfat plus how much butterfat is added is going to equal the butterfat at the end. Okay, our containers are going to be, we started with 900 pounds. We're going to add this time. This is the amount we're adding. And in the end mixture, we're going to have 900 plus the amount that's added. Okay? So originally it's 2%, so that's 0.02. We are adding butterfat. And at the end we want 0.08. Excuse me. Okay, first we need to solve for, or next we need to solve for A. So 0.02 times 900 is 18 plus A equals, multiply 0.08 times 900, and that is 72 plus 0.08A. Okay, we need to get the A's on one side and the numbers on the other. So we'll subtract 0.08A from both sides and subtract 18 from both sides. So this cancels and this cancels. We have 0.92A, which equals 54. Divide times 0.92. And we end up with A equals 58.7 pounds of butterfat. Okay, one more example. Virginia and Campbell had 100 kilograms of a 20% glycol solution. How much of a 40% glycol solution should they add to get a solution that's 35% glycol. Okay, so we're going to do this in terms of glycol because that's what we have. And we're going to have glycol 1 plus, we're adding, glycol added, which is going to equal the glycol final. The original amount was 100. And the end amount is going to be 100 plus A. The beginning percentage was 20%, that's 0.2. The amount of the percentage we're adding, I'm going to move this guy over. The percentage we're adding is 0.4, and the percentage we're ending with is 0.35. Okay? So this is 20%, we're adding 40%, and we're ending with 35%. Okay, multiply this through. We have 20 plus 0.4A equals 35 plus 0.35A. Okay, let's get the A's on the same side. And the numbers on the same side. And we have 0.05A equals 15. And we divide this through. And A equals 300 kilograms. So to this 100 kilogram solution, in order to get it from a 20% solution to a 35% solution, they have to add another 300 kilograms. I hope they have a really big beaker. Okay, that's it for this one. Try your practice questions and let me know if you have any questions.